So what we are doing today is we're going to look at these linear inequalities that we learned how to graph, and now we're going to have a system of these linear inequalities. Remember our systems of equations?
Yep.
Systems of equations where you had two equations, and we basically look for that point of intersection, right? And that would be the solution to the equation system. Well, now we're going to look at inequalities. So I want to do a quick review. This is what we just did last class at this warm-up, is can you graph an inequality of two variables? The answer to that question is yes. So n is 2/3 and b is -1. And stop me if there's something you're not sure what I'm doing. I'm going with, we kind of maybe get this at this point. So we go to -1. This says go up to and right 3. So I will. Up to and right 3. Up to and, I'm off the graph. I could also go down 2 and left 3. Right? Will I make this solid or dashed?
Dash.
Why is it dashed?
Because it's not true.
So these xy pairs on this line will not satisfy this inequality. They are not solutions. Less than, do I shade above? Do I shade below? Below. And this is below. If you're having trouble or you just want to really verify it, what's another way of verifying that this is the correct set of solutions?
Find the test point.
Yeah, what test points are you doing?
0, 0.
If we can, if it's not part of the line, that's the easiest one. So if I plug 0, like this goes away. So is 0 less than -1?
Yeah.
No. Right, now think about it. That's called brains. Since it's not true, this is not a solution, so did we shade correctly? Yes. All right, how do you shade something like that? Y greater than or equal to -3. Is that horizontal or vertical? All right, well, let's try this. If you're not sure, pick 2 points. The y is -3, right? Pick anything else, I don't care what. So 1, -3, 2, -3. Is it going to be horizontal or vertical? Yes. Horizontal. And so will it be solid or dashed? Solid. Why?
Because it's equal to.
Equal to. These are part of the solution. Greater than, do I shade above or below?
Above.
Okay. Y is bigger, above or below? Above. Okay. This one, x bigger than 1. X equal 1 is what kind of a line? Vertical. I'm looking at x equal 1 just to know what the shape is. And if you're having trouble, just put 2 points in. And the x has to be 1. So we go to 1, 2, 1, right? Vertical. And it is dashed. Why is it dashed? Thank you. Greater than is which direction? Where are the x's bigger than 1 on this graph? Over here, right? Aren't all the x's over here bigger than 1? Like this one has an x of 2, and this one has an x of 3. They're bigger. Okay, so that's how we just graph inequalities in 2 variables. We're going to be using that. Now, these are kinds of problems that you can solve using systems of inequalities. I don't know if you've ever gotten an assignment like this. If you haven't yet, someday you will. This is like high school and college. They love things like this. So you have to write a lab report, and there's some rules on it. It can't be more than 12 pages. And of those 12 pages, you can't have more than 8 pages of illustrations, no drawings. And you can't have more than 4 pages of written stuff. Oh. So, like, what are different things you can have? So, for example, maybe you have 7 pages of illustrations and 3 pages of written work. Is that allowed?
Yeah.
Okay, so it's no more than 7 of those, 8 of those, and okay, and it's no more than 12 together. But are there other configurations? Maybe you have 3 pages and 6 pages here. That still works, right? So what are all the different possible combinations? So let's do this. How about we let x equal the number of pages with illustrations, and we're going to let y equal the number of pages of written work. So let's think about what kind of inequalities we can sort of set up here. When you think of any inequalities we can set up, what do you think, Claire?
8 x.
she's so close.
Oh,
She's,
like eight.
now we have to work with our X and Y's. You're so close. Did you have one, Ryan?
Yeah, I
You're
have
so
one.
close. I told
I have
him
one.
before. He's changed his mind.
I have one. 12 is greater than or equal to 8x plus.
Yeah, he's saying 12. Now he's very close. Is that right? 12 is greater than or equal to X plus Y.
No, it has to be equal.
Well, what has to be less than equal to 12?
Oh.
It's what he said. He said 12 is bigger than X plus Y. Is that equivalent?
Yes.
Now, I don't know if I would have thought about it that way. I probably would have thought about it as X plus Y is smaller than or equal to 12. But what you said is equivalent. Isn't it? So the number of illustrations plus the number of written pages has to be less than or equal to 12. Isn't that what that says? All right, is there any other things we can think of related to this sort of situation? Like what? Well, it's the same thing, right? So I want a different inequality now. What else do we know? Can't have more than 8 pages of illustrations. What do you think? Y is less than or equal to. Well, let's have about X, right? Because X is how many illustrations, right? X is less than or equal to 8. Number of illustration pages has to be less than or equal to 8. What else? Yeah? Yes, indeed, right? The number of, the number of
Oh my gosh, that's getting
written pages has to be less than or equal to 4. Okay, hang on, calm down. You guys did a fantastic job coming up with these. This is a linear system, but these are inequalities, not equations. So now we have to figure out how to solve it, and that's why we're here. Awesome job with that. Very nice. Okay. Some vocabulary. What is a system of linear equations in 2 variables? That's 2 or more linear equations with the same variable. So just like with the systems of equations, the x's and y's mean the same thing in all the different inequalities. Here's an example. Y is bigger than negative x minus 2. Y less than or equal to 3x plus 6. It's a linear system of inequalities. The solution of a system of linear inequalities. Think about a solution to linear equations. What's the solution to a system of linear equations? An ordered pair, right? Remember how that works? You have one line, you have another line, that would be the solution. That's equations. Now I've got inequalities. Now, it is true that it's still an ordered pair that is a solution of each inequality in the system. But this one, you know there's only one? Think about what inequalities are. You can have more than one. So you will still see a point, but there may be other points that work. How about a graph of a system of linear inequalities? So we've done the graphing, right? This is a graph of a linear system of equations. It's all the solutions have to be shown. All the solutions. And look what this looks like. So basically, you're graphing these inequalities, right? I've got 2 inequalities, because those are half planes each. And then I look for where they meet up, where they touch, where they intersect. And those are the solutions to the linear system. These ordered pairs are solutions to each of those linear systems. So let's try this, linear inequality graph. So the first step is you graph each inequality in the same coordinate plane, same graph. And then you find the intersection of each of the half planes. Look, that's it. Now the good news with the inequalities, just graph it. There is no, like, we're not going to worry about algebraic solutions for these. Just graph it. Thumbs up, yes. Exactly, thank you. So here's an example. It's kind of a familiar page. So we're just going to graph them. That's step 1, right? Graph them. So graphing a system of linear inequalities. So m equals half, b equals 2, right? Yeah? Okay. So I go to b is 2, right? You're doing this one, it's on the middle of your page there. And this says go up 1, right 2. So I go up 1, right 2, up 1, right 2. Whoops, off the graph.
Down and left.
Thank you. Down 1, left 2. Down 1, left 2. Solid or dashed? Dash. So I make a dashed line. I'm going to put arrows. I'm going to put my little note here that this one's dashed. They do, sometimes they're hard to see. Okay. Now above or below? Less than, below. Now, at this point, be very light with the pencil. Very, very lightly. You just want to be able to kind of tell, okay, it's over here. Just put like some lines. Don't even like color. Just very lightly with the lines like I did up here, right? Very lightly. Don't fill in yet. Don't do this. Some of you are like coloring in. Don't do that yet. Now I'll show you why in a minute. Okay, now we graph the other one. Negative 2x plus 5. You get the idea? Some of you are looking ahead.
Yeah.
Okay? B equals 5 on this one. 1, 2, 3, 4, 5. And this is negative 2, right? Down to right one. Down to right one. Down to right one. Down to right one. Fill up my graph. Is this one going to be solid or dashed?
Solid.
There we go, solid. I agree. And I'm just going to put my little note here because, isn't it hard to tell just looking at it sometimes? It gets messy. And so we're just going to do that. So greater than. All right, now I'm on this line. You got 2 on 1, so you got to be careful now. Greater than. Where's above?
Below the line.
Well, you know what? Let's make a test point. If it's hard to tell, I'm going to try 0, 0 and see if they're here or here. So is 0 bigger than 5, right? Because that would go away. True or false?
False.
False. So this is not a solution. So above's up here. Again, very, 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 very light. And once I do that, where did I shade both lines? Yeah, what's the question?
Like how do you, when you shade the second one, you put the 0, 0 the test point again?
I did. I put 0, 0 in the second one, and it was not true. So I knew 0, 0 is not a solution to the second one. So it doesn't go down there. You have to okay, here it is. Well, don't erase, but you want to make darker. So the part that, look, it was above this one and below that one. If you have a highlighter, I'm going to use a highlighter. If you have one, you can too. That might make it easier to see. Right? It's this region here. Because it's both places, right?
This line's like covering the marker, and then this is the box.
Right. That's why I kind of make my lines look this way so I can tell. It is shaded here because you're right. He was noticing that you see the different hash marks. I'm trying to find a way for you to make it easy to see. That's to me the hardest part is red. So if you have a highlighter, great. If not, use your pencil. But this is the part you make darker. These are the solutions. So every point in this shaded area will make this inequality true and that inequality true. Where are the solutions? They're here. How many solutions? Infinite number. So unlike with equations where there's one solution, there's a whole big piece of stuff, right? Whole quarter of the graph. So that is how you graph them, and that is really it. That's it. So let's try another example here. Look at this one. It's got 3 inequalities in it. That can happen. So you just go ahead and you graph them all. So this one is kind of at the bottom of page 1 here. So y less than equal to 5. I think I skipped something the other, right? A test point. It's worth saying, I skipped something here. How do you know you have the right solution and that you didn't shade the wrong thing? So the way to check, or a way to kind of feel better about it, is pick a point in your shaded area. And I'm going to pick, again, an easy one. I'm going to pick like this one here. What point is that? 1, 2, 3, 4, 0. And what you can do is you can stick it in both places. So 0 less than half of 4 plus 2. That's the first inequality, right?
So
0 less than 2 plus 2 is 0 less than 4. So it works in this inequality. Now test this one. Is, again, I'm using 4, 0. Okay, is 0 bigger than or equal to negative 2 times 4 plus 5? Is 0 bigger than or equal to negative 8 plus 5? Is 0 bigger than or equal to negative 3? Yes. So this region, I picked a point and it did work as well. So that was that bit there. I kind of skipped over it. But if you want to feel better about what you picked, that's the way to check it. All right, let's try this other example. I've got 3. All right, y less than or equal to 5. What does that look like? What's that thing look like? I want that one to be a quick one. Y less than or equal to 5. Is it vertical? What is it? Horizontal. And again, it don't just need your, if you still don't have that, make that little table, pick 2 points. It's y less than or equal. Where on the graph are all the points that are where the y values are less than or equal to 5? 1, 2, 3, 4, I think that's 5, right? And it's going to be solid, isn't it? Because it's less than or equal to. So very lightly. Less than down here. It's hard for me to be light with this little pen here. But with your pencil, just so enough you know, okay, I'm on this part of the graph now, I'm not above. X less than 4, what does that look like? What's that look like, Ryan? Which what kind of line? Vertical. Vertical, right? Yes. And again, make those little tables. If you're still having trouble, pick 2 points where x is 4 and y is anything else. And it is dashed. It's hard to see. See how it gets like really hard to see? So I'll just put that little note here just so we know what we're doing. Now less than. Which way do I shade? Left. Now again, I'm very light and I'm shading over here. But when I get, do I need to shade up here? See where my pen is? I'm not going to bother doing it. I know it's not part of the solution because I have to be under that line here. So I'm trying to, okay, so my solutions are now bounded by these 2 lines. Now I'm going to do this one. Let's see, m is -2 and b is +2. So I go to 2. This says go down to right one, down to right one, down to right one, down to right one, or up to left one. And then solid or dashed. Okay, doing it. There's a solid one there. Greater than. Above or below? Above, where's above? Right here. To the right or to the left? If we're not sure, take a test point. Let's get 0, 0. Is 0 greater than or equal to 0 plus 2? 2. Is 0 bigger than 2? So it's not this. The above is up here. So now when I'm drawing this other thing here, are we starting to see the region that has all of these shadings? And so with your pencil, you can make this darker, or if you have a highlighter, you can do this. This one is bounding a triangle. It's a right triangle. He is geometry ready. So either if you don't have, it's fine if you don't have a highlighter, you don't have to, but this is where you're darkening with your pencil. You want to be very clear that this is the region. Pick any points in here. If you put it in both, all of these, all 3 of these, you should get true statements. So pick a point. If you want to pick like 2, 0, I pick easy points. So if it's 2, 0, is y bigger than 5? Is 0 less than or equal to 5? Yes. X less than 4 is 2 less than 4. Like this one maybe I have to think about a little bit. Is 0 bigger than -2 times 2 plus 2? Is 0 bigger than or equal to -2? That's -4 plus 2. Is 0 bigger than -2? Okay, so it gives me a good feeling. Yep, I shaded in all the right places. What do you think so far? If we get it, do you have questions? Because honestly, that's it. We're already on U-tries. Oh, back to our example. Yeah. Remember we did this? So if I want to figure out this like term paper, my lab report, I could graph all these. So y less than or equal to -x plus 12. I'm going to have to go by 2's, I think. And even then it's going to be tight squeeze here. So I'm going to graph that. Y less than -x plus 12. So 12's up here. Down to right to. Okay, go this one. No, yeah, go this way. Sorry. And I'm still sorry. Okay, so it could be this way. Could be and less than. It would be this way. And x has to be less than 8. That's here. So now I'm going this region, and y has to be less than or equal to 4. That's here. So all this. So what does that mean? You could have 2 pages of, I think that was our illustrations on x, and written over here. So you pick points in here. So if you pick any points in here, let's say you pick 4, 2, it says you could have 4 illustrated pages and 2 rich pages and meet all the requirements. You could have 8 illustrated pages and maybe only 2 or 4 of them, right? So any points you pick in here, I think for these they have to be integers, I guess you could have half page. But it helps you kind of decide what works in this configuration. All right, now we're doing our new try. So go ahead, give these a shot. Let's see, so far, even if you haven't quite finished, it's a little hard to see what's going on here. But you should have gotten something that looks kind of like this, and it's shaded in here, right?
Yeah.
Yeah.
You should have got something that looks, boy, this was hard to see. It's shaded, let me see if I can do this. Shaded in here.
Yeah.
And then this one, it's a little hard to see. It's shaded between like 2 lines in here.
Oh, I did it the wrong way.
Are we getting that right? The correct shadings or the right shapes and everything? Wait, there's a lot going on here. No, that's not correct. All right, let's do that one. I'm going to do C. Y has to be bigger than 2. This is a horizontal line where all the Y's are 2, but it's dashed, right? And Y is bigger? Is that what it says? Oh, look, this is 8. I'm going to change my mind. I'm going to go by 2s, I think. Look at that. It's 8. So I'm going to make these be 2, 4, 6, 8. Just to make it fit. So Y bigger than 2. Bigger than's up here, right? Again, like 8. Like 9. 8, Y less than 8. So here's Y equal 8. Again, both dashed. So now I'm down here. So far, the solution is between. It's bounded by those 2 horizontal lines. Now I have to graph Y greater than or equal to is 4x minus 1. So M is 4 and B is negative 1. Then my 2's now, right? Oh. So negative 1's here. And then I have to go up 4. 1, 2, 3, 4, right 1. 1, 2, 3, 4, right 1. Right, so I can kind of see it. And it's going to be solid. And I want to be greater than. So is greater than above or below? So that's here. Now, if you have trouble seeing it, and I don't blame you, that is a little hard to see. Hit the test point, plug it in, and see where that goes. So let's say it's right here. What do you think?
So that's what
Why am I shading? Because they're inequalities.
and because shading in that spot. Because that's where all
Is that where they all intersect?
Yes.
I want to know where all the shadings is.
Rejoice.
Who has a question? Beginnings? Now, it's very common to go the wrong way. So just you got to be really careful. Your shading has to be in such a way that you can tell where they overlap. But that to me is the trickiest bit. It's really just, if you can graph, you can do this. Who can graph? Who's good? Who are we better at graphing? Raise your hand. I can graph. I can graph.
I can graph.
Graphing.
And if you can graph, you can do this. All right, let's do some more graphs. That's it. Oh, wait, I have a summary. Summary.
Summary.
Here's our summary page. Systems of linear inequalities or 2 or more linear inequalities, same variable. So the graph of the system is the intersection of all those different half planes of the solutions of those inequalities. So you're going to create the graph. You're going to graph each inequality, shade the appropriate half very lightly, and then find the intersection of the shadings and make that part dark. And that's everything. Okay, that's great.